So for people that don't know, what does a naval architect actually do?
Yes. So we design things that go in the ocean, floating or fixed. There are two parts to naval architecture. One is understanding how the ocean affects the structure that you're designing. How does the structure move due to the waves? What are the forces that the wave put on that structure? It doesn't matter whether it's a small wave energy buoy or a huge oil and gas platform or a ship or wind turbines. We'll talk about those. It's the same concept. It's just something that is in the water. So the first part is understanding how that moves. That's called hydrodynamics. Hydro from water and dynamics from moving. And then the second part is, given those forces, how do you design a structure that sustain those structures, that doesn't collapse, that doesn't sink, that doesn't break down? And so that's really structural engineering. So in a sense, naval architecture is not an architecture. My wife is an architect. She designs beautiful things. We don't really we design what I think of is beautiful, but it's not to be attractive to the eye. We design efficient structures to go in the ocean. So first, the hydro, and the second is the structure. Talking about architecture, I was 5 or 10 years ago, I was giving a talk at the AIA, which is the Architecture Association from her. And I took, so we don't see it, but San Francisco is on the background over there. And we have one landmark building, which is the Transamerica Tower. You've probably seen it. I had taken a picture of the Transamerica Tower. I have put it sideways in the bay under the Golden Gate. So Photoshop with the other building. And I was telling the architect that everything that's on their structure, we have mechanical, plumbing, electrical things, but we're not connected to the earth. So we're self-sufficient out there.
Right.
But that's really kind of the same thing. It's when we design things at sea, we have to be self-sufficient in terms of power, in terms of communication and survival.
Yes, self-sufficient, reliable, and everything has to be designed so it can sustain the worst weather. Yeah.
And we can't sink. Unless we're a submarine, but then we have to go back up.
I mean, similar to the airplanes, that the airplanes cannot stop, in the middle to fix something. You can stop, but, you cannot sink. Yes. And I find that fascinating, that concept, because when you're getting into those type of trips, you're getting, you're putting your life on the captain's hand, right?
Yes.
And everybody's on the same boat, right? Quite literally, right?
It's funny, it's the same, the captain of an airplane and the captain of a ship.
Yes.
Same word.
Yes.
The same thing. He's in charge.
He's in charge.
Or she's in charge.
Yeah. And the coordination of the whole team that makes everything happen, right? Because, single mistakes can make, Yeah. I was reading recently there was a boat, a Mexican boat that.
Yes, I heard that. Where the people fell down and died, and so it was stranded, and then it was on a current in the river, and the boat lost power and started going backward. And the people that were up in the mast went under the bridge. They cut the mast and 20 people died, I think.
Yes.
Falling off the mast. Yeah, it's a very, very sad story.
And that's, and it was supposed to be a routine procedure, right?
Yeah.
So everything they do when they're on the boat can become mission critical, right?
Yeah, I don't know a lot about what happened. I just saw the videos and I was heartbroken. But clearly, there was multiple steps that did not happen. And why did those steps not happen? That I don't know. But first, there was a lot of boats and tugs next to it that we saw. Why didn't they come in? And those boats have anchors. Why didn't they drop the anchors? That was my first reaction. As the captain sees that he's drifting towards the back, you try to stop the boat. And I think that the other thing that happens is people freak out in those type of things. So I think there was definitely an element of, okay, this doesn't work, and eventually you run out of time. So preparation and practice and making sure that all your safety. So in offshore work, we spend a huge amount of time worrying about safety.
Right.
And that's very important. When I started my career working for Exxon, and it was, everybody comes home, no casualties, no, taking care of the people. And you repeat it over and over and over again so that it becomes embedded in people's mind. And that's very important. People have safety minutes and you're like, okay, but why another safety minute? But it's this constant repetition that you have to think about safety. That's very, very important. But even though you do that, you still sometimes have tragedies.